How many of you have ever been in the situation where your Kubernetes have some issue and then you thought maybe one more command I need to run, maybe then it will rotate. ये मेरे जैसे कि मैं perfect. Then go fancy sort of the AI scrum. It is the practical scenario where as a ops engineer day to day, what kind of the challenges I have seen and to solve that problem, what I can do. My name is Ali Sharma. I'm principal architect. I help my team day-to-day tasks to make the Kubernetes functional well and work on the real world scenario application where the critical component is the thing. I have a feeling as an ops engineer, maybe in the middle of a night, you see your baby is crying, you are tired and you have to wake up back, take care of it, no matter the situation, but you have to fix it. No matter the reason, the blame is on you because it is crying. And the situation is like a baby, we don't know why it's crying. And like a mother, we need a good sleep. That is a problem I found, and I've worked on it because I'm also a part of that. The problem is not like understanding. Kubernetes is more with a loud technology. It produces a lot of things. It explains many scenarios where we have to go through by each to understand everything. So when something is break, we don't just debug. Actually, we explore and explain. That's what we do in most of the cases. So here, my core idea is, can we make a cluster who can self-explain the problem? Again, like a mother who expecting Rocky to make it fix. Now, we don't like dashboard, right? We have a good dashboard. We don't like kubectl commands. And we have a lot of way how we can get everything from the kubectl. The real challenge is when we are in the under pressure, when something is already broken, then we need a way to get it fixed. So, in the under pressure, what exactly we need? We need shared understanding. What do you mean by the shared understanding is Kubernetes, every service is not itself just a service. It's a combination of a lot of things. So understanding is a very critical part where we have to go through by each problems to understand. So when there's a problem, people guess this can be a problem. People blame because of this issue. And then people stuck in a loop. So I keep build a trap. And I thought, why every time? And then one thing is going to clear in my mind is every scenario when we have an incident to fix something. So the time we are spending is to restore our understanding, not fixing the problem. So more understanding we need, then only we can fix a problem. It's full for a second length of people settle. But those the 7 reps I have seen, some guys become very loud suddenly. Let's start with the guess. We seen an error, we guess. Maybe DNS. Straightforward answer. Come on, Vegan. This is one of my favorite ones. Be stating the pod. Maybe it should say something But the problem in the node. Command dot. He either command, big data result, we have a loop, then feel like no, I have to run one more command to see what meant. Feel like playing a guess game with the Kubernetes. And we going through with the multiple commands to understand what's going on. And sometimes even we lose the track, what we are looking. The third trap is copy paste fake. Now, the copy paste fit is exactly the way where we ask to the AI. That's the simplest one. We copy the logs, paste to the ChatGPT, and ask, right? And then one more is go with the blink first. And then the specific is silence. And this is very frustrating. Remember, you have seen a Kubernetes giving an error. And it's saying nothing about the problem. The screen staring at you and you. And the best one nowadays called hero mode. So what is the hero mode? The enhancement version of copy paste fit. So I have imagine, this is the seventh trap, my part. If you guys relate to that, maybe you also know the pain I have faced. So in hero mode, I have 4 windows. A terminal where my Kubernetes is connected with the errors, and one browser which have the ChatGPT or some kind of TI tool open. Now I copy the error, paste to the ChatGPT, and then ChatGPT say, run this command in the terminal. And then I copy the command from the ChatGPT, paste from the terminal, and then terminal say, hey, it's the new error. So I copy it back, go to the ChatGPT, and paste it back. And then ChatGPT say, hey, there's one more issue. Let's check this first. And then after half an hour, you have no idea what's going on. Somewhere back in your mind, you thought that maybe you pick some be super technology. You know that AI is not good. Maybe I don't know how to use AI. Sort of things came here, Christian. And the specific moment, sometime I realized neither I know AI and the good it is. So life's hard. Kubernetes is like a graph. Think this way. A pod is connected with node resources, image pool, logs, events, and so many resources. So there is no single point that explaining what's going on. So we have to go through by each services to understand which one is broken. Because, like a mother, we have to ask every single kid who did that. And everyone says, I wasn't. So, to fix that, like a mom, you need evidence. Who did that? What was the cause? What is the error? Track down the error with a root who actually producing the error. See, most of the people getting stuck nowadays. Like I explained, remember? One UI of ChatGPT and the terminal work. Same scenario. You look at the cluster, they copy output, ask AI, run more commands and repeat. Now, the problem is we never know what we are fixing. And what we become the API. API is more like, even though that's, not a good thing to respect API. API even have something to cross verify. Even we don't. Think like here, a mindless person who doing a copy paste between terminal and charger. And this way we never back from the situation how to fix it. I thought, can we connect the AI safely directed to the Kubernetes, and the goal is get the result with the safety and with the focus. So there the transparency is something which I feel like deterministically possible, but free parameter has to be the part to get the real answers. Most of the AI come with amazing experience, amazing improvisations. And Gandhi is needed so we can see or understand what it is saying rather than is it helping me to fix it. To achieve that trust, the trust can be achieved by when see the evidence and the executions. And those evidence can be generated by a truthful source. That is the goal I'm trying to follow to produce a product which can help. So, so what I found is my architecture idea is let's not make handover my Kubernetes to LLM. We know that what AI can. Instead, I thought maybe I can use LLM for what it best, intent understanding. So once we have the intent understanding, we can say or the deterministic evidence to get what's going on in the cluster, like the logs, events, or something. So the phase one is more like we have a question like why my some kind of service is not working. So we understand the intent of a user and then we stop the LLM here. Once we know the intent, we figure out what kind of the evidence is needed to answer this question. To get those evidence, we need an architecture who understand the evidence and validate against the cluster. That's very important. And suppose we have a history with the cluster. How many times my pod failed in last 1 month? We have those kind of question, right? If a pod is crashing for last 3 days, then we need to know why it is crashing in recent few days. What was good last week? What something bad we did 3 days before? So these kind of a question need evidence. So what I did is I converted my framework in 5 questions after understanding the intent. That should be easy for you to see. So what is the inventory? Hell, diagnose, how to, and semantic. So same cluster, same data, different intent. That is possible, right? And some most failure happens when system pick the wrong intent if we use the LLMs. To conclude that, we have made routing the first class feature. So this is going to be over first class of the layer to understand how we're doing with the cluster. We detect question type how we can make the right query in the cluster to get what we need. So here if you see like how many namespace has become see, let's see the why. So why my pod is failing me is become the diagnose and so on. So we categorize each type of the question in the 5 sections. So we have a semantic system also the part of it. Semantic is a way to understand the intent. So it's have a feeling. Maybe I have seen this before, but if you go keyword by keyword search, you will never get the same result. Every time, if there any image school error, the behavior many same, but the error statement always different. So you cannot go by searching the entire keyword section and all the logs, and every time you get the same results. The behavior is always changed when there is an error. Here, the semantic help us. The semantic understand the log meaning. So the image pool maybe have a different type of the logs, but using the semantic, we can get the meaning is almost similar. Now, semantic help here with just the some initial steps to get the evidence. Like if we need to get the evidence, we need to know from where we need to start looking. So the semantic help us to simplify where we should go and start. And then the evidence jump in like we have seen the 5 steps. Some portion are way of this. How many namespace I have, what kind of the namespace we got, how many services we have, number of the services we needed. Do we have any server which don't have any endpoints? Sort of the obvious questions we can understand and get the answer so fast. So we don't rely on the LLM itself to ask such simplest question and we can skill. So the LLM is becoming the last layer when the question have the system is struggling to understand the intent of the user. Till we have a system who can understand the query and get it the output. I go with the performance. So the speed strategy says that do we have any way to select all the logs and explain it what's going on. So let's go with a simple example. I will back to this slide in the more detail. The problem I have seen becoming the human API is we don't know what specific command we need to learn to get the outcome, right? Now, what if I tell you the system is helping you to become someone? Like you ask how many namespace which does not have thoughts. So the system will identify, collect everything and give you the outcome. At the same time, it will give you the set of the commands. Next time, use those commands to get the same output. So you can run the same commands, you can get the same output. So you can see that system is reproducible and you can trust with that system. So the next time, if you don't have that system functional and up, maybe somewhere you gain some knowledge that you can reproduce and make it functional like. Only on that road, to be honest. Because my main goal was to introduce the problem which I have seen. If you are in the same family, maybe it will help you that.
Here is the flow. There are only 4 steps. If you remember nothing else, remember this. Clarify the input, normalize the intent, route to the right template, and deterministic execution. So the system can be wrong, but it cannot be vague. Now I'm going to run setup.sh. That script creates a demo playground because live clusters are unpredictable and demos shouldn't be. After this, I will create 7 namespace and few more predictable failure modules like 1 image pull error, 1 crash loop, 1 pending schedule case, and couple of healthy workloads. Because the goal isn't the showing Kubernetes works, the goal is to show how we debug when it doesn't. Let's verify the reality, that's important. I'm not trusting my system yet, I'm trusting Kubernetes. So here are the namespace and here are the pods across all the namespaces. You will see few are healthy and few are initially going to be broken. So that's perfect. Notice the pods in the image pull back off, error image pull. We will use that. Now let's start the brain API. Let's source the environment first. And we need to run the make brain command. So think of like an ops copilot, but with strict rules. It can only answer using evidence it can fetch. In another terminal, you can see that V is running. So we're going back to the terminal, quick health check. First, a simple inventory question. What I want to notice you is the system written the answer and it tells you the exact kubectl commands to verify as well. This is how trust is built. Total list of namespace. Let's try again now to see the names. So you see we listed 12 namespace resources with the example, and we also get the command how we can actually check the namespaces. Let's one more try. In the past, do we have any issue with the image pull before? And one thing to notice is I said in past and before. So this is a historical question, not a current state question. So the current behavior is first check the semantic memory, search for similar incident, and only if the memory is empty, fall back to the live cluster state like but clearly labeled as fallback. If your system currently returns only the current pods, say right now if memory doesn't have history, it will fall back to the current state. In production, we treat it as a gap. We explicitly say no historical evidence found rather than pretending. Let's take two more quick examples. One is why the image build is failing and why the demo says not working. So here exactly you can see the falling is explained that the pod is waiting to start, trying to failing to pull image. And again in the crash loop back, you see that it's going to explain about state of the current claim, like it found 2 pods in the error state out of 20, and here's the pending one and running one, and the crash loop back and the image pullback definition is also added here. Plus it's also given you the verify commands that you can use to validate all the status of the current pods. So what did we really build? Not a chatbot, a workflow. Question, correct route, deterministic evidence, answer you can verify. And once you add semantic history, it becomes a cluster that doesn't just show symptoms, it remember patterns. Thank you everyone.
We didn't same the space the same scenario. So either we focus on becoming the human API or produce a system who understand the intent at the same time help you to real fix a problem. That is more important. So do anyone have any question about it?
Yeah, we didn't have questions. The big